I'm getting rather bored just sitting around here. We need some excitement.
Say, remember a few Centron units back when Sammy and I found that planet over in the Milky Way? Well, we taught a rather low form of life how to start a fire. Oh, it was great fun. They were so primitive.
Taught them how to start a fire, eh? Egad! What was the name of this planet?
Oh, I think it was called Earth. Oh, they were very excitable creatures.
Sounds like fun. Maybe these Earth creatures will be ready for electricity. That should really turn them on. My, it looks as though these Earthlings have caught on rather quickly, wouldn't you say? So much for teaching them about electricity. From the looks of things, I'd say they've already started using computers.
You just might be right about that. Oh, this is getting exciting. Now, who would have thought that all this would happen just because we showed them fire?
I know. Let's see if we can find some poor chap in need, eh, what? Maybe we can lend a hand or three.
Let's look in that building there. Well, at least they're trying to use computers. I think we've caught them in the early stages.
Gad, they do look primitive.
Yeah.
It's Clyde.
Oh, hi, boss.
You're already 6 weeks late. How much longer?
Well, I've almost got the problem isolated. It's in the left side, I think.
You think? Better Business Machines is already threatening to sue us. We'll be out of business. What does it take to test your new model?
What does it take? How about a little magic? All I'd have to do to make the bug disappear is say abracadabra.
Hello. Zounds! Blue jeans! Oh, we've never been able to make those here. I say, old chap, how much for your pants?
Ah. Oh, that was... No.
Calm down. Calm down. We won't hurt you. We just want to talk to you about your company.
Are you guys from Better Business Machines?
No, but we do have some information that might get you a promotion.
Who are you guys?
We want to tell you about a new way of diagnosing system faults.
Well, that was...
We've noticed that you're having trouble testing your system.
Hey, that baby is the fastest, most compact, lowest power techno-datalyzer in the universe. Well, the Model 1 sure sold well in the U.S.
Ah, yes. But what about in 1987 when the bottom falls out of the market?
You must remember the rule.
Sorry.
Now, you certainly do have rather an impressive techno-datalyzer there, but you've put in so many feedback loops and sequential logic blocks that you've rendered the bloody thing virtually untestable.
Untestable? Everything's testable. I'm testing it right now. At least, I was.
Please, take a seat. But have you isolated the problem? And have you done it within a reasonable period of time? Now, one of your Earthlings wrote a rather appropriate definition of testability. A circuit is testable only if a set of test patterns can be generated, evaluated, and applied in such a way as to satisfy predefined levels of performance, defined in terms of fault detection, fault location, and test application criteria, within a predefined cost budget and time scale. Fairly advanced for an Earthling. Must be related to us somehow.
I say, old boy, I think your test procedure needs to be tested.
Well, don't worry about that. Once production picks up, we'll just install a bed of nails tester.
They are rather expensive. Besides, you have to take the system apart to test it, and the tester could even damage the boards. Now, what if the problem arises only when the system is completely assembled? For instance, during temperature cycling, you can't take the system apart. You need a method of system-level diagnostics.
Well, at least for board-level testing, the bed of nails tester is the most efficient.
And the most expensive.
Still, what are you going to do for field service? You can't have a complete bed of nails tester in every field office. How are your field technicians going to do their work?
They certainly can't do what you're doing now for every problem that comes up, old chap.
Okay, well, we'll just add a few more jacks on the boards and maybe a few muxes around the places that fail a lot. That'll make field service easier. No problem.
No solution either. That still doesn't give you access to all those feedback loops you have buried deep within your system. Now, you know that the typical computer system can be broken down into a data section and a control section. Commonly, there is no external access to the control section. You've added extra hardware, but haven't gotten much further inside the system.
Then how about software-based diagnostics? A few extra lines of microcode will get you right into the heart of the system.
A few lines of code? Oh, you silly unit. You're going to need a few chips of diagnostic code. Either that or you'll have to cut back on your system microcode that you've already got, old boy.
Haven't you guys heard about writable control store? I mean, I use static RAMs for the microcode. All I have to do is load in some diagnostic code instead.
Yes, but you're still going to have to reserve space for part of your operating code anyway.
That will give you limited control of the data section, but you still won't have control of the other parts, and you've not gained any observability at all.
What's all this controllability and observability garbage? All I want is to build a techno-datalyzer that's a good product and won't cost too much to maintain.
You have already designed the good product. But to reduce maintenance costs, you have to make the system more testable. Now, testability is a function of controllability and observability. Think of testing like a video game. In order for the video game to be any good, you have to have controllability, the joystick, and observability, the screen. In the same way, a system test is only good if you can control the interior status and then observe a future state.
But I already have controllability of the inputs and observability of the outputs.
Yes, but for complete diagnostics, you need to control and observe every single key node within the system in order to truly isolate a fault.
Now you're talking about LSSD, Level Sensitive Scan Design.
Oh dear. All those poor human units who bought stock in better business machines back in the mid-80s when...
That's still no good. You have testability, but you're going to have to sacrifice some of your system performance.
Why's that?
Because you don't want your system to smoke, unless you want an expensive barbecue.
Look here. LSSD shifts through your output latches. If you happen to have this set up and two consecutive ones in your test vector, you will enable both of these devices onto the bus at the same time. That is called three-state overlap, or a bus fight. Only one will win. That overstress on the system often only shows up later. You will have to add extra time-consuming logic to prevent that or other unwanted conditions from happening.
Even then, you're going to have to go offline for a while during the shift procedure. For a large system like yours, it could take a long time to do a complete series of tests. It would be better if you could shorten the interruption during the test sequence, or stay online during the whole test, old boy.
Ah, forget it. I don't care about this stuff anyway. I'm perfectly happy with my scopes.
Ah, yes, but your boss Clyde isn't.
Dirty wrecker.
Those wonderful additions and changes you have made to the Techno-Datalyzer have increased performance and reduced the price, but the cost of ownership has also increased.
Increased? How? The Model 2 cost $200 less than the Model 1 did last year, and it's got a 20% improved throughput. How can it cost more?
Because when it's down, old bean, its throughput is 0, and your system is down much more than it used to be.
Look here. The overall cost of ownership takes into account maintenance costs along with other costs you are not considering. You have indeed saved $200 on the components, but since production must buy new test systems and do additional testing, the cost of production has increased. You have to remember that the cost of testing is proportional to the number of gates squared. As MSI chips go to LSI and VLSI, test cost increases exponentially. Your new system requires more maintenance, and with the rising cost of labor for field service, you are really increasing the cost of ownership. The extra losses due to increased downtime negate your throughput savings.
Your field service chaps are already just swapping boards until the problem goes away. You can't afford to have 10 to 15% of your company's assets tied up in spare boards, you ninny.
Well, you haven't given me any options. What would you do, Mr. Alien?
Well, I'd just use a robot or probe X-ray. But the rules don't allow us to talk about that.
Have you ever considered adding a serial scan loop to your system?
I already told you that's LSSD.
Oh no, this serial scan loop is separate from the normal output register. The scan loop is in what is called the shadow register. Now look here. The shadow register acts as a shadow of the output register. It can be transferred in parallel either to or from the output register. In normal mode, the shadow register is independent of the output register and operates as a serial shift register. Test data can be shifted into the shadow register while the output register continues its normal operation. A transition to diagnostic mode allows the test data in the shadow registers to be loaded into the output registers. The entire system is cycled, and the test results are transferred from the output registers to the shadow registers. This data can then be shifted out while the system continues its normal operation.
Great. You've just added another chip for every register in my system.
We haven't added a thing, you git. The scan loop is buried in the same chips as the registers.
Oh. So you mean this shadow register has its own clock, yet it's on the same chip as the normal register. But to control the test sequences.
All you need is a simple controller that can provide 4 signals. A system clock, a diagnostic shadow register clock, a mode control, and a serial data input. It can be a supercontroller of the entire system. And with the freedom it gives you to design as you wish, you'll probably even reduce your overall chip count over the other methods of diagnostics.
Besides, old boy, the diagnostic controller can be an extension of the hardware that loads your writable control store. Diagnostics will add almost nothing to your system hardware.
But it'll add a lot to system software. If you'll just provide me with a few seeds to generate some test vectors, I'll come back next year and show you what I got.
Sorry, Food Eater. Next year we're vacationing at Alpha Centauri.
Actually, adding scan loops breaks your system down into combinatorial blocks. Since you can control every register, you can set the sequential logic blocks to any state and test the transition to the next state. Combinatorial logic is much simpler to write test vectors for. You don't have to concern yourself with cycling the system repeatedly to set up the desired sequential state. Instead, you can go directly to it. Combinatorial logic testing is well understood by you Earthlings, and there are many algorithms available for test vector generation.
Well, you've got all the right answers from me, but the company's going to have to get in on this. This will require approval from everybody, all the way from the test engineers to the vice president of engineering.
Do you believe it? Those ape descendants have discovered red tape all by themselves.
Well, just tell your vice president that he can reduce the need of bed of nails testers, reduce his field personnel, reduce the number of spare boards in inventory, and reduce the downtime and maintenance costs of his equipment. He can even do remote diagnostics over the phone. And since you know how to test the system before it is built, you can quantify the savings. Now look here. Even with a small increase in parts costs, you lower your production and maintenance costs, giving you a lower overall user cost. And you do not have to give up your increased throughput. Ideally, you should build a totally modular system, enabling the customer to perform the maintenance function either from his own stock of spares if he needs 100% uptime, or supplied by express mail from a major support center. And if you want, you can use this technique to do on-site repairs, since your fault isolation is so good.
Besides, you boson, this will be the accepted method of diagnostics within 5 Iticons.
Quiet, you keep breaking the rules.
Sorry.
What are these rules you guys keep talking about?
We are strictly forbidden to tell you anything about the future. We can only teach you what your world currently offers.
What? Then that means this diagnostic shadow register thing is already available, right?
That's right! It's available from Monolithic Memories in a standard format. It's called Diagnostics on Chip. Doc! Look there. Presently, the 8-bit registers and registered proms have this feature added to them, and they're called the Diagnostic Register and the Diagnostic Registered Proms. Soon it will be available throughout their entire family of products.
When can I have some? How fast are they? Do they have characterization data? Do they come in plastic and ceramic? Are they in production? Scan loops, MMI, doc, shadow register, diagnostics. Wow! My boss will love me. A raise, a promotion, a vacation in Alphazen. Now. Clyde! Hey, Clyde!
Egad, teach those puddles of pondering protoplasm something advanced, and all they can think about is their own primitive interests. He can find all that information at MMI, now that he knows where to look.
That was quite fun, though, wasn't it? Better than teaching them about fire, wouldn't you say?
Oh, yes, yes, jolly good fun. Just an egon of a thought, though. If they advance this far after learning how to make a fire, how far can they go now?